Welcome to Off Hours, a conversation between Jon Edwards and Chris Manning.
Now, you do quite a bit of lost wax casting. For people who may not be familiar with what that technique is, how would you describe the art of lost wax casting?
Wax casting is a technique that is sort of fundamental to the jewelry making world. One of the interesting things about jewelry making is that it is sort of a black art for people. They see jewelry, they're familiar with jewelry. Most people have at least some kind of jewelry in their life, whether it's buying jewelry for a spouse or whether it's wearing a wedding ring or an engagement ring or something. But most people have no idea how any of it's made. That's why I kind of refer to it as a black art. And there's a great Asimov quote, I think it is, or Arthur C. Clarke, I can never remember. And he says in one of his books, any sufficiently advanced technology is indistinguishable from magic. And I think in some ways, the same can be said for any sufficiently ancient technology. People don't really understand how things work because we've sort of forgotten about it and we ignore it. We don't teach people about it anymore. Casting is one of those processes that people just don't understand anymore. In the jewelry world, we primarily use a technique called lost wax casting, and this technique is thousands of years old. And really, other than slightly more advanced materials, slightly more accurate ways of heating things and whatnot, the process hasn't really changed dramatically in that time. So with lost wax casting, you start with a master model of some kind. As the name suggests, it's typically made out of a wax. It started out being made out of anything that was essentially combustible, something that you could carve and you could turn into the thing that you eventually wanted in metal, and you would carve it out of this combustible material. Once you have a model that you're happy with, you then wrap it in something that's going to be able to handle the high temperatures required, first of all, to burn out that original model, and second of all, be able to handle the temperature of the metal that you're going to be pouring into it, because you're going to pour molten metal into it afterwards. Today we use an investment plaster, like a plaster of Paris, that can handle very high temperatures. Today I make my models out of wax. I put them into investment plaster into a mold, and then I burn out the combustible model, so in this case the wax model, and leave a void in that investment plaster. Once the void is there, I can then pour molten metal into it and replace where the model was with molten metal. And I now get a perfect replica of that master model. One of the interesting challenges of it, though, is that, as the name suggests, lost wax, you're losing that wax. You're losing that model. If something goes wrong with the cast, you've lost that original model.
Do you have a favorite go-to wax? Not all waxes are equal, and I would imagine you're not just going out into a field and grabbing some beeswax and using that.
Yeah, most people, when they think about wax, they think about paraffin wax or they think about beeswax, because that's what most people will have access to in their daily life. And honestly, the wax that I use today, it's designed as a jeweler's wax. And for most people, it appears more like plastic than it does like wax. It's very, very hard. And the reason for its hardness is so that it can hold detail. If you take a look at something like beeswax, it's very soft and it's very difficult to work in accurately because it is so soft. You can leave your thumbprint in it quite easily, which isn't ideal. But if you wanted to carve very, very fine detail in it intentionally, it's quite challenging. So, and even something like paraffin is very soft compared to the jeweler's waxes that we use. We use waxes specifically for the jewelry industry, and they've been designed to be hard enough to carve accurately, but still be able to melt out sort of between 325 and 400 degrees Fahrenheit.
What's your preferred way to prepare the waxes, to shape the waxes for casting?
So in my case, I'm making pens, and obviously I need to make things that are cylinders. I need them to be reasonably accurate cylinders. I use a number of different methods for making the wax barrels and caps that I then cast into metal. Primarily, I'm using a lathe to turn them into cylinders, drill out the holes that I need to in the blank. And then I'm often using either hand tools to carve them, or I'm using a computer-controlled mill, a CNC mill, to use a very, very fine cutter to then mill out the detail in the barrel. And when I say a fine cutter, the tip of these cutters is around 5/1000ths of an inch across. Just to give you a point of reference, a sheet of paper is around 3/1000ths of an inch thick. So this is just slightly under the thickness of two sheets of paper, and that's the tip of these cutters. So they're very delicate cutters spinning at high speed, and I can then use those to carve out the very, very fine detail that I want in the pen barrels and caps that I'm making.
Now, is there a particular material that the cutters are made from that you tend to prefer for working in wax?
Carbide cutters are the only way to go. They're very, very hard. They can handle the higher temperatures and speeds that you need to use. When you want something very sharp, you need a very hard metal. And so the harder the metal, typically the sharper you can make it. Now it becomes brittle, which is a challenge when you're making things like knives. But in the case of cutters, you want something very, very hard and therefore something you can sharpen quite a bit.
What does your workflow look like for designing the pen, sort of from initial idea through to something that's ready to be cut out in wax?
Nearly all of my designs start out in one of two ways. They usually start out as a reference photo that I've taken somewhere or I found somewhere. My camera is an essential tool when I'm traveling, and I'm usually photographing details, primarily architectural details, but any interesting detail that I find when I'm traveling, I'll take a photo of. And from that photo, I'll usually start sketching something. So I'll, just using pencil and paper, or these days, a lot of times iPad and pencil, and sketching what I want to do with that design element. Because oftentimes that design element is buried in amongst a number of other things. And it's important to sort of pull out the detail that you want and make it stand out, bring some clarity to that particular detail that you want to use. From there, I can then build a 3D model of the pen that I want to build. And for that, I'm using Rhino 3D. It has some excellent tools for being able to then pull in those sketches and pull in those photographs as references. And then I can use them to build the pattern that I'm going to use and refine that pattern even more. It also allows me to use, to build a 3D model that I can see the proportions of the thing that I'm making. I can put models of other pens that I've made in there. I can compare them to them so I can see, okay, this is a little bit too big, this is a bit too long, and sort of get a sense of the proportions. It doesn't always work out, but it saves me a huge amount of time in terms of making something that later on I go, oh, wow, that's much too large or much too small. The 3D modeling certainly helps with that. From there, I can then turn that 3D model into a program that the CNC mill can follow to mill the pattern out of the wax barrel that I've created. So I'll create an oversized wax barrel, and the mill will then cut away all the material that I don't want and turn it into an original model for that pen. And one of the important things, because this is lost wax casting, every single pen needs to have its own original model, because that model will get destroyed as I cast it.
Mm-hmm. One thing I do know about casting is that shrinkage occurs. So what you're actually starting with in terms of wax and what you arrive at in the end product, you're going to put the original wax beside the metal, just because of the nature of physics and molten metal cooling down, that they're not going to be exactly the same size. How do you account for that?
There are a few challenges when it comes to casting. That's definitely one of the more challenging ones. And fortunately, the type of casting that I'm doing, I have less struggle with that. Now, one of the things I didn't mention, the jewelry industry wouldn't get anywhere if, in terms of mass production, if somebody had to manually make a model every time you cast a wax. One of the inventions of 20th century, I guess, in terms of casting technology was the use of vulcanized rubber for making a mold of something that you've made. You would make a wax original, a master, cast it in metal, clean up the metal, polish it, and do everything you need to do with it. And then you would surround it in rubber, heat that rubber up and vulcanize it. So you would then create a perfect rubber mold around this metal original. You would then cut open the rubber mold, and you can then inject hot wax into it. You can create a wax master from this rubber mold, pull it out, close the mold again, inject more hot wax, let it cool, pull that out. And so from this rubber mold, you can then produce thousands of copies of that, that metal master. but now you're doing it in wax. So it saves you the time of having to, have somebody hand cut or even CNC cut, a wax original for each one.
Mm-hmm.
In that technique, again, when you're mass producing for jewelry, so a lot of the jewelry that you're going to see in stores, department stores or in mall stores or whatever, most of the jewelry that you're seeing there was produced in that fashion. They made an original, they cast it, they cleaned it up, they then made a mold off of that original, and then they're injecting waxes based on that. And when you're dealing with that kind of jewelry production, that kind of casting, you really have a challenge of shrinkage. So in that case, the rubber changes in size as you're heating the rubber to vulcanize it and sort of melt it around that original. You get some shrinkage from that rubber. And then as you inject it with hot wax, that wax also shrinks as it cools. And so you get a little bit of shrinkage from that as well. And with that, you can, depending on how good you are and what materials you're using, you try and use as low a pressure as possible when you're injecting the wax. You try and use as low a temperature as possible when you're injecting the wax. There's some room temperature rubbers that you can create, some silicons that you can use now for making molds, so you don't get a lot of shrinkage from the rubber. So you can keep it down as low as maybe 3 to 8% shrinkage in a situation like that. Now, in my situation, that doesn't work out very well. There are a few challenges of injecting waxes when you're talking about the objects that I'm making. One is that they're quite long and narrow, and so trying to get the hot wax to fill that entire cavity is challenging. And then you also have problems of it's easy for that to distort because it is wax that you're injecting in there. It's hot wax and it's a rubber mold. And so you can get distortion, barrels that aren't quite straight, barrels that aren't quite cylindrical. On top of that problem, you've got the shrinkage. 5 or 6% shrinkage doesn't sound like a lot, but when you're making parts that interchange with each other, or you're making parts where the pattern is important for it to match up, that 5% shrinkage is quite a bit and can cause problems.
Even 1% in watchmaking would be a deal breaker for interchangeable parts.
Oh, absolutely. And fortunately, I'm not dealing with parts that require that level of interchangeability. But you're right. And this is one of the reasons why you can't cast a lot of parts for a watch, because the accuracy just isn't there.
Mm-hmm.
With the wax that I use, it is very hard. It is something that I'm machining. And the nice thing is that I don't get any shrinkage from that wax because it's already been cast into its solid shape and I'm removing material from it. I don't get any shrinkage from it because I'm not heating the wax up again as I'm machining it. I'm cutting that wax away. And fortunately, between, some experimenting that I did with the types of investment plaster that I use and the burnout process that I use and things like that, I'm able to keep the shrinkage down to what's effectively nil in my parts. The critical dimensions for me come in threads. And so in your case, in watches, you're dealing with gears that have to interchange. A thread is really not that different in a lot of ways than a gear. There are tight tolerances in that you don't want the thread to be too sloppy, and so you don't want it to be too loose. But you also don't want it too tight, otherwise it won't close up. Just like if you make a gear to mesh too tightly, it'll bind on you. And so the same thing happens in threading. You don't want a thread to perfectly engage 100%, otherwise it'll never overcome the friction that you have in there, and so it'll just bind on you. And so in a case like that, if I'm working with a part that ends up being cast that needs a thread on it, so let's say, for instance, the interface between the barrel and the cap, there's a thread there that allows the two of them to thread together. I will actually cast that oversize as a solid cylinder. And then once it's in metal, once it's in silver, I will then turn it down to the final dimensions and thread it at that point. So instead of threading it in the wax, I'm actually threading it in the silver that I eventually cast it into. And that's how I get around dealing with any sort of problems, any sort of warpage or shrinkage or anything like that.
For investments, do you have a go-to investment that you prefer for casting silver? And does it change for other materials like palladium?
In the case of silver, I'm using a product called Satin Cast 2000 from Kerr. It's quite good. It handles the temperatures that I need, the temperature range that I'm working in quite comfortably. It also handles the detail that I'm looking for. So of course, one of the things that you need to make sure is that if whatever you're using as your investment plaster, it's effectively the mold that you're casting into. And so if that material can't hold the resolution that you need, you're going to lose that resolution. So if you think about the difference between a coarse sugar that you might use to decorate the top of some cookies, and you compare that to icing sugar, which is very, very, very fine. It's the same kind of thing. If you tried using that very coarse material as your pattern, as your mold, it wouldn't hold the fine detail that the very, very fine one could. And so if you want to think about the investment plaster that I'm using, it has a consistency very close to icing sugar. Now, when it comes to other metals, the biggest issue that you get with other metals is the temperature that you end up casting them at. So in the case of silver, I'm casting them, sort of somewhere around 900 to 950 degrees Celsius, which I guess works out to around 1900 degrees Fahrenheit. Most gold you end up working with is cast in a similar sort of temperature range. Once you get into metal like platinums, palladiums, white gold, which often has palladium in it, the casting temperatures go up dramatically. So in a case like that, you may be casting at 28 or 2900 degrees Fahrenheit. And so you need to use investment plaster that's very specifically designed for that. Otherwise, the investment plaster will break down and you'll then lose all your detail because the investment plaster is crumbled inside of the mold and you no longer have the accurate mold of what you're trying to cast in there. And because of that, I don't actually do a lot of casting in the higher temperature metals. I'm not really set up for that.
Do you ever run into trouble with air pockets in the investments? And what measures do you take to try and reduce any buildup of air pockets within the investment?
It's worthwhile talking a little bit about casting technology and how I simplify it by saying, well, you're pouring the metal into the mold, and it goes a little bit beyond that because, of course, if you just try pouring the metal into the mold, it won't. You will have air pockets in there, and you'll have problems. It won't fill that entire void in the mold. There are a few ways you can deal with it. If you're dealing with very large scale casting, like let's say you're casting a large bronze, you would use effectively gravity and the mass of the metal above it to drive it down into the mold. So if you have to keep the mold at a high enough temperature and the metal at a high enough temperature that it will stay molten long enough to sort of fill in all those gaps. But of course, when you're dealing with precious metal, that becomes impractical. We don't want to pour 500 pounds of gold at a time. So the trick on a small scale is to then simulate that that gravity and that mass. And so there's a few ways of doing that. Traditionally, a jeweler would have probably used sling casting. And so the idea in sling casting is that you have your small flask and it's tied to a leather thong, chain, whatever you have, rope. And the lucky guy gets to stand in the middle and he's going to then spin the flask around. And the unlucky guy is the one with the crucible with the molten metal in it, and he pours it into that flask and then ducks basically while the person then in the center then swings it around as fast as possible. And you basically using centripetal force generates the force to drive all the metal down into those pockets. Now, I say the unlucky guy on the outside because the reality is that sometimes the bottom of the flask blows out and you then have molten metal spraying everywhere.
Or the guy in the middle lets go of the sling,
Well, yeah, the guy in the middle lets go of the sling. That doesn't, or the rope breaks or whatever.
All sorts of potential points of error.
Yeah, so the guy in the middle doesn't have to worry about any of that because, of course, he's in the center. And so it's it's always going to move away from him. So he's pretty safe. A lot of places that do casting today, especially small scale casting, still use a similar method. So nowadays, when you go into your dentist and you need a cap done on your tooth or whatever, it's just as likely that they'll mill it, out of a solid block of porcelain or something like that. Right? They'll use a CNC mill to mill it out of a piece of porcelain. But even a few years ago, when people were getting metal molds or metal caps and whatnot done on their teeth. Those would be cast at a dental technician's, and those dental technicians would be using sling casting effectively to do it. And in this case, instead of having somebody stand in the middle of the room and sling the flask around, you would have a centrifugal casting machine, which is essentially an arm mounted around a point of rotation and a heavy duty spring that would sling it around. And so you would pour your molten metal in and then knock the lever, and it would then go spinning around a couple of times, and that centripetal force again from the spring would be enough to drive all of the metal into that mold. Now obviously today it's much safer. There you put a barrier around the outside of it so that if something happens and the mold blows out the bottom of it or whatever, you don't have molten metal spinning flying across the shop. A lot of small jewelers will do that if they're casting their own work. If they're doing custom rings or whatever, they might cast their own work, and so they'll use a centrifugal casting machine like that, just because they're inexpensive, they're very easy to build and maintain, and you get reasonably good results out of it. There are a couple of other ways that you can cast. In my case, I use a vacuum caster, and when you start getting into industrial level casting, places like, let's say, Rio Grande, who are casting their own findings and whatnot, they're using large vacuum casting setups. And there are a lot of advantages to vacuum casting setups, primarily in that you can get that very, very fine detail and fill those molds easily on a much larger scale flask. If you imagine with a centrifugal casting setup or a sling casting setup, if you have a very large flask, you then have a lot of mass and a lot of inertia flying around, which then becomes dangerous to deal with. In the case of vacuum casting, you don't have anything flying around. It's sitting there inert. And so in the case of my setup, I have a casting machine with a crucible at the top that heats the metal. It has a graphite crucible, so the graphite can handle the temperatures we're talking about. There's a graphite plug that sits in the bottom of it. Below the crucible is the chamber with the flask in it. I use a vacuum pump to draw the oxygen out of there and the atmosphere out of it. Between gravity and the vacuum, when I pull the plug on the bottom of the crucible, the metal then goes tumbling down into the flask. Gravity obviously pulls it down, and then the vacuum also pulls it down, and it pulls any gas or any atmosphere out of that flask.
So why graphite?
Graphite's reasonably inexpensive. It's easy to make, and it handles very high temperatures well. It doesn't break down easily with temperature, so I can reuse a graphite crucible many, many times over and not have to replace it. Of course, one of the things that you want to try and do is reduce the consumables in something like that, where you're constantly doing it over and over again. The casting machine that I have is designed for low volume production casting. I can cast a kilo of silver every 12 minutes or so. If you imagine let's say you're a small shop and you're setting up to do a dozen flasks once a week, and each of those flasks is somewhere around a kilogram of silver. You don't want to have to replace that crucible constantly. You want it to be able to last. So graphite happens to work well. It's not horribly expensive when it comes to replacing them.
The current market rate for silver, you could burn through a good chunk of coin pretty fast, casting a kilogram every 12 minutes.
Yeah, you certainly can, and it'll do. I think it's like 890 grams of gold every sort of 14 or 15 minutes. So yeah, you can spend a lot of money on material if you're casting in volume. At some point in the future, I'm sure we'll talk about some of the rapid prototyping technologies that are out there, and you can use. There are laser sintering devices now that actually fuse metal powders together in printing. And a gentleman I was speaking to at the Santa Fe Symposium last year, he has a platinum laser sintering device, and they fill that. I think he was saying, is it 6 kilos of platinum per printer? So you start doing the math on that, and just to be able to do a basic print, you realize just how much money you need to spend on material. So yeah, one of the problems in the jewelry world is that your raw materials are quite expensive, and
Hmm.
it adds up pretty quickly.
Yeah, I would imagine to keep one of those laser sintering machines going, you'd need something like $250,000 to $500,000 worth of precious metal powder sitting there in a tub.
Yeah, unfortunately, I don't have to deal with quite that much metal, but
Mm.
the just to do a basic cast of my pens. Now I'm not going anywhere near the full kilo, but still, you need sort of 400 or 500 grams of material just to cast a basic flask, because you do have a sprue that goes down the center of it that carries the metal to all parts of the flask, and that takes up 200 or 300 grams of silver. And then each of the pen barrels that you've got in there, they may end up weighing somewhere in the order of 40 or 45 grams each. And then, you've got a half a dozen of those in a flask. So it doesn't take long before you start putting, $500 or $600 worth of metal through a flask just to do a basic cast.
Mm. Now, in terms of optimizing material usage, do you use any software running any like specific gravity calculations to calculate the weight of what you're machining in wax before you go ahead and cast it?
So one of the nice things about the modeling tools that I use is that I do have the ability to generate volume measurements from the model. So I can tell from, in the software, okay, this is going to be, X volume. One of the interesting things about the wax that we use in the jewelry industry is that it has a specific gravity of 1. You can weigh the wax and then multiply it by the specific gravity of the metal you're working in. So in my case, let's say the wax is 1, the silver is, let's say, 10.3. If I have 10 grams of wax, multiply it by 10.3, and I'll end up with 103 grams of silver is how much I need to be able to do the cast. So it's quite simple for me to be able to figure it out.
Mm-hmm. So is this something that you keep in mind throughout the modeling process, or do you just kind of let your creativity run free and worry about it at the end of the day and just make sure that things are priced accordingly to cover costs?
I can effectively make any size or shape of pen that I want, but the human hand is only, there's only so much variation in the human hand between people. Even someone with a small hand versus a large hand, there isn't a huge amount of variation in there. And so you need to sort of work within a set of parameters that makes it comfortable. You can't make it too narrow, or else it's uncomfortable to hold. It's too, your hands cramp up holding it. You can't make it too large, otherwise you feel like you're holding a toddler's crayon, where it's an inch in diameter, and it feels weird. You don't have any fine control over it. So when it comes to sizes, there's sort of a range of sizes that I work in. And then on top of that, there's also weight. And you don't want something that's too heavy. You don't want something that's too light. As I mentioned in episode 1, balance is also important. So you need to make sure that the mass of the barrel is closer to the nib where you're writing, so that it tips forward a little bit, and it writes it pushes down against the page. And so as I'm modeling it now, some of this is just through experience, and I know that the wall thickness has to be roughly this much so that it casts properly. I know that once I start getting up into past a certain weight, that it'll become uncomfortable for people to write with. Some of it's experience, some of it's experimentation, and saying, okay, this, casting different sized pens and saying, oh no, that's way too heavy. Nobody's ever going to want to write with that, or it's too light, and so it's uncomfortable for some people, or for the size of pen that it is. So it is something that I have to think about through the process. But fortunately, I've been doing this long enough now that I don't have to think about it a lot. I know sort of what the acceptable range is. So I know if I've gone over that, then I have to dial it back and figure out a solution. And then of course, cost becomes an issue, right? If the heaviest pens that I make are somewhere around just shy of 100 grams, just a little over 3 ounces. You start dealing with precious metal costs. Well, you make something that's twice that weight, all of a sudden the metal cost goes up dramatically when you're dealing with silver and gold. So that is something that you have to be conscious of. You don't want it to be too heavy, or otherwise nobody will be able to afford the pen.
You mentioned the hazard of investments blowing out. Do you know why an investment might blow out and what sort of measures a person could take to guard against that?
There's usually a few different reasons why your flask ends up breaking apart, and they are certainly things that you can do to avoid them. So the first is overheating the investment plaster. When you're mixing up the investment plaster, you're mixing it with water, and then of course you don't want that water in there when you're casting. If you pour 1900 degree metal into something with water in it, that water is going to flash and turn into steam, and then of course that molten metal is going to come straight back out at you because the steam needs to expand so much. So you need to dry that investment plaster, and that's part of the burnout process, is that as you're burning out the wax, as you're melting that out the bottom, you're also driving off the water that's in the investment plaster. And then to allow the investment plaster to handle the temperatures that are required for the molten metal, you need to essentially activate it. You need to harden that investment plaster. And in the case of the plaster that I use, that happens at around 1350 Fahrenheit. And so the flask will be left in the kiln for several hours at 1350. Now, if you go too high with that temperature, then the investment plaster starts to break down. Same thing if the metal that you're pouring into it is too hot, that investment plaster will break down. If you don't bring the investment plaster up high enough in temperature, then it's not strong enough, it hasn't set properly, and it will also start to break down. So that's one of the things that you can do, and that's effectively, from a chemical point of view, you can change the way that it works by changing the way that you heat the investment plaster as you do the burnout. The most common way that people have failed flasks is by not having enough investment plaster between the bottom of the metal where the metal's going, so the mold that you're making, and the bottom of the flask. If you imagine, let's say having a barrel with a very, very thin bottom on it, and you put too much force on the bottom of that barrel, it's very easy to break through it. So you need to make sure that there's enough investment plaster at the bottom of it, because of course all that metal is now being forced down into it, and you don't want that force to then break through the bottom of the investment plaster. So as long as you leave enough material there at the bottom, it shouldn't be a problem. One of the problems with centrifugal casting is that the molds, the flasks that you're pouring into, tend to be very small, because they tend to be designed for dental work or small scale jewelry work. So if you try, for instance, in my case, I can't get away with using most centrifugal casting machines because I'm casting pen barrels that are, let's say, 3 inches in length, and the flasks are not large enough to handle the 3 inches of model plus sufficient base material to stop the metal from sort of blowing out the bottom of the flask when you hit the lever and get the centrifugal force going.
No, another aspect of casting that most people might not realize is you actually need to design what it is you're going to cast in such a way that it can be cast. Because there's certain forms or geometries, if you will, where the way that gravity and centripetal forces, or even a vacuum operating, works, where if you have say a very thin area leading into a very thick area and down to a very thin area again, or a whole bunch of loops of this, that you might not actually get enough metal flow to fully fill what it is you're trying to cast. I haven't had too much experience with molten metals myself, apart from just casting straight billets to roll or draw out into thin wires. But for this past Mother's Day, I actually designed a set of earrings for my wife. It was just an interesting process, actually, having to think about this for the first time, in the way that the structure of the earrings were being designed, and the flow of the shapes and the material. Just working back and forth with a friend of mine on that, who's a jeweler, and just getting to the end result there, and then just having to think through that whole process opened my eyes a bit that way as well.
You are dealing with a liquid. You can't have the material come back on itself. So if you imagine if you have the gate going into the part, you can only have a void below that opening. If it's above that opening, the metal can't then come back up and fill that it can't come back on itself. So it does become challenging in some cases to make sure that you've got a good enough flow of metal so that it can actually flow into all of the spaces that you need to go into, and also so that the wax can flow out when you're burning it out. And then, as you say, dealing with thin sections and very thick sections of a part is the rate at which the metal cools. A thicker section of metal will cool at a slower rate than a thinner section of metal. And so if you have a very, very thin section and you're trying to feed all this molten metal into a large heavy part of the casting, that metal will basically freeze in the thin section, and you won't get a full fill. If you look at the overlay pens that I do, those often have very, very thin sections, and they have intricate patterns. And one of the challenges that I struggle with when I'm casting those is getting the metal to fill all parts of that lattice work, so that the metal doesn't freeze before it's filled the entire thing. And I should mention that one of the reasons why I started casting my own work is that it is challenging, and it needs different temperatures of the flask and different temperatures of the metal to cast properly. And they're sort of outside of the norms of what most jewelry casting houses use. While they're certainly capable of casting them, it would be very difficult to put my work into the same flask as, let's say, some standard wedding rings or engagement rings, where they're much thinner, they're much smaller, and so you can't cast very heavy, thick objects in the same flask as something that's very, very light and very thin. They need different metal parameters when it comes to temperatures. So that's one of the reasons why I ended up casting my own work. It was difficult to find casting houses that were willing to do the extra work to cast just for me.
Another way for kind of dealing with flow issues within a cast is to build in extra channels. It's kind of like what you would see as a support material in a 3D print, but rather than for a 3D print, it's an extra channel for molten metal to travel through to fill a certain area, or to exit through, or to pass on to another object.
Yeah, that's called a gate. And so the gate connects from the sprue into the model itself, and sometimes those are for carrying metal in, and sometimes they're for allowing gases to void out of the part. You don't want those gases in the model that you're casting. And so sometimes you end up with you're always going to end up with extra material around the part itself that you then have to cut away. And so sometimes that's a challenge as well, because you then need to be able to attach those to the model somewhere that it's not going to affect the pattern that you've put into your model. Because of course anything that you put on there is going to obscure the pattern underneath. So that certainly is a challenge.
Yeah. So you want to keep that sort of thing to as much of a minimum as you can to effectively minimize post-processing and avoid messing up your patterns.
So the parts that I make always have places on them that will have smooth surfaces that I can then attach the gates to, and that way when I'm casting, I have somewhere to cast into, and it's not going to affect the pattern at all. Now, one of the other challenges that you end up having with cast materials is porosity.
Yes, that's what I was going to ask next.
Porosity is a problem where the metal isn't as dense as you want it to be. It could be because of gas. It could be because of because of voids. The metal just doesn't fill as much as you want, and so porosity can be a huge issue that you have to fight with. And again, that it comes down to having the right parameters when you're casting, and that's primarily to do with the temperatures. Because the flask temperature itself is important. If it's too hot, then the metal doesn't cool fast enough. If it's too cool, then the metal cools too fast. The metal temperature itself, most people think of a metal, or as liquid as being sort of, it's either a solid or a liquid. You think about water, for instance, and water, it's either frozen as ice, it's liquid as water or it's boiling and it's turning into a gas. When you're dealing with metals, something that becomes more obvious is the fact that the temperature that something starts melting at is not necessarily the temperature that it's liquid at. So you have the solidus temperature, where below that temperature the metal is solid. You have the liquidus temperature, where above that temperature it is a liquid. In between those two temperatures, it's sort of an in-between. It's think about slush, for instance. Like you buy a slushie, and it's not really ice, it's not really solid, but it's also not really water, it's not a liquid yet. So there's that slushy stage in the middle. You need to be well above that point. You need it to be a liquid, otherwise it's not going to flow properly. And so you need to make sure that the metal is high enough in temperature that it flows, but you also don't want it too high, otherwise you then can have problems with it. Sometimes it's issues where the metal then becomes brittle. Sometimes it doesn't cool fast enough. So there are interesting issues that you have with that. So fighting porosity, you can combat that in a couple of different ways. You can change the temperatures. You can also put heavier areas outside of your casting. So in the gate that leads up to it, you can put, let's say, a large ball near where where that gate enters the part. If there's any sort of porosity, if there's any sort of any expansion of gases or whatever, then it's going to happen there as opposed to in your part itself. So there's different ways that you can fight off porosity. And unfortunately, if you have a part that's too porous, then it leads to problems with polishing later on. You can't get the polish that you want on it. If you're trying to set stones into it, then you can have issues where it's just not hard enough to securely set a stone into the metal.
And alloys must play some part in that as well.
In my case, I tend to be working in silver. It's relatively easy. We're dealing primarily with sterling silver, which is 92.5% pure silver and 7.5% pure copper. Sterling silver has been a standard since the 11th century, and just so happens that it's a very nice alloy of silver. But I also tend to work in argentium silver. And argentium is similar in sterling. It has an extra percent of fine silver in there, so it's 93.5%. But instead of the balance being made up of just copper, there's also a very small amount of germanium in there. The balance is made up of copper. And that germanium has a bunch of advantages. It makes the alloy harder when it's at room temperature. That's an advantage for me in terms of pen clips, for instance. They're not going to bend as easily and misform. It also doesn't tarnish as quickly as sterling silver does. If you've ever looked at old silver spoons, for instance, you'll see that they tarnish if somebody isn't diligent about polishing them. And argentium doesn't tarnish as quickly as sterling does. But at the same time, that also leads to other problems where if I cool the metal too quickly after casting, then it can actually make the argentium very brittle. There are different challenges with each alloy, and depending on what you're using, you need some sort of experience to guide you in terms of how to work with it.
Coming full circle, looping back to the beginning a little bit here, we're talking about your design process there and how you often come up with new ideas while traveling. And I find traveling to be an excellent way to just launch yourself into beginner's mind. If you're going somewhere brand new, everything's all new to you. Just to close things out for us, what's one experience in particular traveling that you would say has had a pronounced impact or a memorable impact on your work in crafting your pens?
The primary inspiration for my work, it tends to be architectural details, and that came from traveling through England as a kid, being very attracted to the classic Gothic architecture of the 12th to 15th centuries. And so it becomes very prevalent in a lot of the buildings that still survive in England. And then as you get into the Victorian age, they started reusing that Gothic architecture again. And so when you look at things like the Houses of Parliament in London, and you see the heavy Gothic architecture there, same thing here in Ottawa. The Houses of Parliament here in Ottawa have a very heavy Gothic design sense to them. I was sort of introduced to very strong design of Gothic architecture quite early on. And so I do use those kinds of elements in some of my overlays. I think most recently, the heaviest influence of a culture that I wasn't familiar with was from a trip that we did to India in 2012. I wasn't familiar with Indian art or architecture at all before I went on that trip. So for me, it was quite eye-opening. I had no experience with it at all. While I was there, I took a lot of photos of the shape of buildings, the shape of columns, and also the marble work. There's some gorgeous marble work in India. When I came back from that, one of my pen designs, the Jaipur, that came directly from a black and white marble pattern that was surrounding the room in the Red Fort in Jaipur. I saw this beautiful, very graphic pattern in the marble, and it was perfect to be able to pull those elements and those details out and turn them into a pen. The Taj Mahal is very, very busy, and it has great design details when you're looking at it from 2 kilometers away. And as you move in closer, it starts to reveal more and more detail that you can see. And so there's always something new that you can see as you move in on it, to the point where as you then get up and you're standing a half a meter away from it, there's even more detail that you couldn't see when you were standing 5 meters away from it. I then took some of the details that I saw when I was up close and some of the patterns that I found when I was looking at it quite closely, and then sort of extracted key elements from that and turned that into a pen. So again, there's a pen up on my site right now that comes from those design elements that I found while I was looking at the Taj Mahal. So yeah, that was certainly the most eye-opening trip in the last 10 years in terms of how it directly translated into the work that I'm doing.
This has been enlightening, Chris. Thank you. I look forward to hearing more about your travels and what goes into the work that you do in future shows.
Thanks for listening to Off Hours. You can find detailed show notes at offhours.show. If you'd like to keep up to date with the show, follow us on Twitter @offhours. Jon can be found on Twitter @UnderTheLoop, and Chris can be found on Twitter and Instagram @silver_hand.